if the Wronskian of two functions is -4 times et and one of the functions is given by e raised to 2t, find the other function. So the Wronskian of f and g is given by this function. F is also given e raised to 2t, and let's find the derivative, exponential function itself times the derivative of top, which is 2, and we need to recover the function g. Let's look at the formula for Wronskian. Okay, we know that the Wronskian of two functions f and g is given by this 2 by 2 determinant, which is same as f times g prime minus f prime g. Okay, so which I wrote here. Let's write down the given functions and find the unknown. So the Wronskian is given as -4 e raised to t. F is e raised to 2t times g prime is unknown because g is unknown, so g prime minus f prime is derivative of f, which is 2 times e raised to 2t times g is unknown. Okay, so e raised to t, e to t, e raised to 2t. We can divide through by e raised to t, or look, this is g prime g. Okay, this is a first order linear because we have like unknown function g and its derivative, and t is independent variable. So let me rewrite in the standard form. So move both this right hand side to the left, so which is same as e raised to 2t times g prime as a function of t, by the way, if you want to write this, minus 2e to the 2t g. Basically I'm just writing whole left and right hand side into the left is equal to minus 4et. Now let's divide by e raised to 2t, okay, which is non-zero, so we can always divide by e raised to 2t. Then we get, now we need to separate into two fractions. Okay, e to t cancel, so g prime t minus this 2e to t cancel, 2 gt is equal to -4 e 1 copy of t, this is 2 copies, so t minus 2t. So if we move e raised to -t, okay, 1 copy of et cancel. Basically e raised to 2t is same as et times et. Okay, when we multiply we add the exponents. And now this is a linear equation, linear ODE in g. Okay, that's the dependent variable with respect to t, and to solve we find the integrating factor. Okay, so integrating factor mu as a function of t is e raised to antiderivative of this function, which is -2 dt, which is e raised to -2 antiderivative of 1 is just t plus c, but we just write e raised to 2t. Okay, now we multiply this differential equation by the integrating factor, then we get the left hand side will be always automatically derivative of dependent variable, which is g, times the integrating factor, which is e raised to -2t, is equal to, now right hand side multiply this by the integrating factor, you get -4 e to the -t times e to the -2t. When we multiply we add the exponents, -1t, -2t, -3t. Okay, now integrate both sides. Okay, then integrate both sides with respect to t, then we get this dt cancel, just pretty much this function gt times e raised to -2t, and the right hand side -4 antiderivative of e raised to -3t, exponential function itself, divided by this coefficient, which is -3, plus some constant of integration c. Now to find gt we divide by e raised to -2t, so gt is, that's the unknown function, divide by e raised to -2t, so negative cancel, 4/3 e raised to negative 3t divided by e raised to negative 2t on the bottom. So negative 2t cancel, 1t left, so e raised to negative t plus c over this, so c over, when we move to the top, okay, that becomes e raised to positive 2t. Okay, and if you want, you can take c equals 0. Okay, then this is a function, but this is the general function, and where c is an arbitrary constant, you can take c equals 0 and give the specific function, but you can just leave here final.